how did our universe begin?
The concept of sort of the enormity of the universe and the enormity of space tends to make me feel, I guess, small by comparison.
Questions that have intrigued scientists, philosophers, and the rest of us for thousands of years.
Why do some people study the stars? Well, you look up at night and you want to know what's out there.
Was there really a God that said, "Let there be light"?
I think the universe is so complicated that you almost can't rule anything out. I mean, it's endless possibilities.
Hi, I'm Angela Baracchio-Gray, and welcome. Today, we'll be talking to Nobel laureates, Templeton Prize winners, and other scholars, all who have made it a point to study cosmology.
Cosmology is a scientific study of the origin, evolution, and structure of the universe, including the examination of time and space. Observations from our past, such as how the universe began, can give us clues as to where it's headed. But more than anything, cosmology eventually comes around to examining how we got here and why we are on this planet. But wait, we're getting ahead of ourselves.
Science is a marvelous tool. Science is telling us how physics is playing its way out in the physical universe. Science is a wonderful tool to tell us how gravity works, how chemistry works.
We can look further back in the universe than maybe people really thought possible with true observations. We can speculate further back with real theories. And as scientists, that's what we try to do. We try to recognize what it is that we can measure, what it is that we can make predictions about.
The story of the universe is a fascinating story. It starts very, very simple, an almost uniform expanding ball of energy. And then over these billions of years, through evolutionary processes of one sort or another, it has become very rich and complicated. With human beings, as far as we know, the most complicated consequences of that long, long history.
And here we are. Human beings are part of the consequence from a complex history. What are we a part of exactly? If we go way, way, way back to the beginning, what was the origin of the universe? What was this singularity? You probably know it as the Big Bang. Before this Big Bang, there was nothing. And then, bang! That colossal explosion of energy and matter gave birth to everything in the skies, the planets, and the universe. The Big Bang also created space, time, gravity, and all the laws of physics. Radiation and matter shot out in all directions. The universe then started to cool. Gravity caused matter to clump together, and stars were born. Later, disks and rocks gathered around the stars. Several billion years later, we have a planet called Earth.
The beginning of the universe was a unique occasion. Nobody was there to watch it. So it's all wonderful deduction as to exactly how it happened.
Okay, so there was no one there to witness the Big Bang. Who came up with this theory of the origin of our universe?
How did they come up with the Big Bang Theory? I really don't know, but I would think that astrophysicists had a light bulb moment.
Meet the man who had this light bulb moment. One of the first people to present new ideas about the beginning of the universe was Father Georges Lemaitre. He was a Belgian priest and astronomer who, in the early 1920s, proposed the theory of the origin of the universe, which he called the hypothesis of the primeval atom. Lemaitre said, a cosmic egg exploded at the moment of the creation, and the universe has been expanding ever since. Very few scientists initially embraced Father Lemaitre's theory. Albert Einstein dismissed it because he refused to accept the concept of an expanding universe. But later on, he came around and endorsed Lemaitre's theory. Then Lemaitre became a pioneer in applying Einstein's theory of relativity to cosmology. But that was almost 100 years ago. Since then, a lot has happened in science and technology. We've discovered many more of the universe's secrets and mysteries. With all the progress in science and space exploration and research, does the Big Bang Theory still hold up?
To answer that question and to answer some other questions that may arise as we explore these issues, I'd like to introduce Dr. Stephen Barr, renowned particle physicist and author who teaches at the University of Delaware. Welcome, Steve.
Thanks, Angie.
So what about this crusty old theory? Does it still hold water?
It does. In fact, there have been key scientific discoveries that support Lemaitre's theory. You've heard of the Hubble Space Telescope. It was named after Edwin Hubble. Back in the 1920s, Hubble used a telescope that stood atop Mount Wilson in California and discovered that ours is not the only galaxy, but that the universe is vast and filled with countless other galaxies. And what can be bigger news than discovering the skies filled with billions of galaxies? And Hubble discovered something even more amazing. All of these galaxies were flying apart from each other at incredible speeds. The universe itself was expanding.
I don't see how Hubble could have came up with that explanation. I mean, he wasn't there, so I really don't know how that's possible that he was able to come to the conclusion that gases were spreading.
Here's how he came up with that realization. Light coming from something moving away gets distorted or redshifted. Sound does something similar. Here's an example. Watch as this car drives by as the driver annoyingly honks the horn. Listen to how the sound changes as the car races away. In the same way as sound waves from the car shift to make a different sound as the car moves away, the light waves from galaxies flying away from us shift to appear as a different color. We call this redshifting. Hubble understood that the redshifting of the galaxies happens because they are moving apart from an initial explosion. This means that space itself is being stretched bigger and bigger and is carrying the galaxies with it. And then came Robert Wilson and Arno Penzias. They were two radio astronomers who worked for Bell Laboratories. They were studying the microwave sky to potentially use it for microwave communication. This was in 1964, before cell phones.
So I worked very hard using a fair amount of the stockholders' money. In those days it was thousands of dollars, which is not a lot, on liquid helium to cool a noise standard so I could compare the galactic halo to some source of absolute temperature.
They built a very powerful antenna, but they kept hearing static, a background hiss that filled the entire background sky. They tried everything to get rid of the noise. After consulting with a team of Princeton physicists, Penzias and Wilson had a eureka moment.
You look at a star, the star's out there all day, and the reason you don't see them in the day is because light's in between. We know about stars because we measure the darkness next to them. But when you're inside the Milky Way, you can't turn away from it, and so we had to have something like that, and that's what I built, a standard of noise. And I expected that noise standard to be cold, a little bit warmer than the night sky.
The only way something could be in every part of the sky is if it was part of a cosmic event.
And there is also the cosmic background radiation. As the universe continued to expand, of course it got cooler and cooler, after nuclear reactions had stopped, there was still the interaction between radiation and matter. And that stopped atoms as opposed to nuclei. It stopped atoms forming until the universe had got significantly cooler. And that took about 500,000 years. When the universe had reached that age, then the interaction between radiation and matter stopped. And so the radiation was left behind, just lying there, so to speak, throughout the whole universe. And as the universe continued to expand, all that happened to that radiation was that it got cooler and cooler.
And that's what happened. So what we are seeing is the echo of creation, not of creation, but we are seeing what happened in the first 3 minutes. That's where we started.
It would seem like the Big Bang Theory would be the go-to answer then for how we got here.
But it's the job of scientists to find the best theory to explain a set of data.
The Big Bang is a tremendous misnomer because it concerns the moment of beginning where suddenly there was all this energy in the form of photons of light, literally, let there be light. And in the first milliseconds, these photons of light change into matter, and out it comes in a huge, explosive rush out. There wasn't really any noise connected with it, but it gives the idea that something suddenly happened, and suddenly there was something rather than nothing.
The Big Bang itself is a singular moment. The whole universe seems to be contracted into a single point. That means it has infinite energy and zero size. And that's so an extreme a circumstance that science itself can't describe it. It's what we call a singularity. It's beyond science itself. So we can get near to the Big Bang. Our thoughts take us backwards in time. We can't get to the actual moment of origin in itself. That's beyond science's power to penetrate at the moment.
So it doesn't tell us what happened in the very beginning. We don't know what happened. And even our theoretical tools break down, because when the universe is so hot and dense, we don't know how to make calculations. We need both quantum mechanics and gravity, and we don't yet know the theory that can do that. We might ultimately have such a theory, but right now we don't.
The idea was that galaxies are moving away, but they're constantly being replaced because matter is just being created in space and new galaxies are formed. In the meantime, some nuclear physicists had a different problem. Where'd the elements come from? Where the sun turns hydrogen into helium. What about all the other elements?
Even though the Big Bang is the accepted theory, that is a lot to accept. From nothing came something. Well, not something. Everything. How is that possible?
We have so much to talk about, but let's first back it up a bit. Scholars have been considering the universe for thousands of years. My question is, what did scholars think before the Big Bang?
Now, Angie, if you look back through history, you see there were two different approaches to looking at the universe. In ancient times, all the Greek philosophers and scientists agreed that the world had always been here. Aristotle's universe, for example, was made of huge spheres going round and round forever, with the Earth at its center, like a giant clock that had been ticking forever. There was no conception of other solar systems or of other galaxies.
But for ancient people, cosmos was a living organism, and a living organism has a soul or a mind. And they thought that the universe, the cosmos, also has a soul which is responsible for the order and for harmony in the universe.
Now, when modern astronomers like Copernicus and Galileo came along, we began to understand that the Earth is not the center of the universe, and that the universe is much bigger than people originally thought. We went from looking just at the solar system with the sun at its center to embracing a vast universe with hundreds of billions of galaxies.
The ancients had different views about the beginning of the universe. Quite a lot of them thought the universe had always been there, that it was everlasting.
Now, what's really interesting about this is that Jews and Christians, of course, had held to the idea that there was an actual moment of creation, even though the science of the time couldn't back that up.
Jewish thought portrayed the universe as coming to existence at the word of God. God said, "Let there be," and the world came to be. So that, of course, did lay an emphasis on the universe having a finite age and having a definite beginning.
Cue the 21st century. There have been so many amazing technological advances. We continue to expand our knowledge and understanding in both mathematics and science. Is it possible to come up with a better theory of what went on at the Big Bang? Current cosmologists are trying to crack that mystery. And to do that, they're coming up with interesting theories of what might have happened before the Big Bang.
There has always been some discussion about whether something preceded our present universe. Might there have been a universe that would have collapsed and gone down into a black hole, and then out of that black hole came the present universe?
One theory that attempts to get even deeper into our past, farther back into the beginning, is appropriately called the bouncing universe theory.
Bouncing universe theory means, I would say, it's a theory that maybe a bunch of elements just started bouncing around.
All the galaxies are flying apart from the force of the Big Bang explosion. But in this scenario, their motion is slowing down because gravity pulls them back together. So eventually, the expansion stops and reverses. The galaxies are now flying toward each other, faster and faster. They all merge into a fiery mass called the Big Crunch. Now suppose this fiery mass explodes again. That's the bounce. And the whole process repeats over and over. Each bounce is another Big Bang.
Well, people speculate about what might happen in the very, very early universe. They speculate that maybe it emerged from the Big Bang because it was bouncing back from a previous contraction. That would be a sort of cyclic picture of the universe, out, back, out, back.
Okay, so there's one problem with this theory. If you look at a bouncing ball, you'll see that not all bounces are alike. If a universe bounces, it turns out that the interval between bounces would get longer and longer. So if you rewind time and look at the bounces in the past, you'll see that the interval between those bounces was shorter and shorter the farther back you go. If you add up all the bounces in the past, it still just adds up to a finite time. So the universe had a beginning after all.
Okay, so there are problems with the bouncing universe theory that some physicists still can't accept. Are there any other ideas about the origins of our universe?
There's another idea that has to be considered here, what physicists call the eternal inflation scenario.
Eternal inflation is the idea that the universe, as it expands and gets bigger, could, in the process, generate other universes.
The basic idea here is that the universe we see is just a bubble within a much larger universe. And the Big Bang was just the event where our own particular bubble formed. The larger universe has been going on for much longer than that, maybe forever. In this larger universe, bubbles would be forming all the time. Inside each bubble, there could be a universe much like the one we see. And the space between the bubbles is expanding, much faster than the space inside the bubbles.
We actually see evidence that there was an explosive expansion of our universe early on. And the question is, was this the only place this happened, or could it be that there are other places? And again, this is a connection between what is the underlying theory that determined this explosion and just the fact that there's evidence that this explosion happened at all.
But why stop at eternal inflation? Can we think more out there to describe what's out there?
There's a fairly new theory called the Steinhardt-Turok, or ekpyrotic theory. The word ekpyrotic comes from the Greek meaning intense and uncontrolled fire or explosion. This theory is a kind of bouncing universe on steroids. This model holds that the Big Bang was the result of a collision of our own universe with another universe that is moving along some hidden extra dimension. That crash released a lot of energy into each universe. That energy forms into matter and then galaxy. The galaxies move apart and eventually fade away. And the idea is that the two universes crash into each other over and over again. In order to get your head around the ekpyrotic theory, you have to comprehend string theory.
Only of recent times have I heard of string theory. I'm not really sure what it means. I get the picture of like a messed up cat's ball of string.
What's string theory? It's another relatively new concept. It's the theory of everything. Everything in our universe is composed of vibrating strings of energy. For the theory to work, there have to be more than 3 dimensions we see. There are 10 dimensions plus time.
People speculate that something called string theory tells us how to combine together quantum mechanics and gravity, but it's not fleshed out enough that we really know how to make predictions with it. That we can do some calculations, but there's many we can't do.
Okay, so here's the problem. Physicists say that it's impossible to have what's called a perpetual motion machine, a machine that goes on forever without wearing down. That is a problem for theories in which the universe has been going on forever, like a perpetual motion machine. The universe is far from being worn down. The amount of entropy is still pretty low, and at the time of the Big Bang was very, very low.
Notice that in this model, the Big Bang is not the beginning of the universe.
So the thinking is that this could have been going on forever.
The answer seems to be no. Not as we currently understand the laws of physics, especially the second law of thermodynamics.
The second law of thermodynamics says that disorder increases with time. Entropy, which is a measure of disorder, increases with time. And the most disordered state, the state with the highest entropy, is the state of thermal equilibrium, where everything is at the same temperature. Now, the universe, of course, is very far from being all at the same temperature. There are hot stars and there's cold space. So our universe is far from being at a maximum state of entropy, even today.
To summarize so far, our examination reveals that the bouncing universe, eternal inflation, and ekpyrotic theories are all fascinating, but none of them are able to prove anything beyond the Big Bang. They can't show with certainty that the Big Bang was not the beginning of the universe. However, we should still examine one more trendy new theory that some scientists say might blow our ideas of the Big Bang out of the sky.
The multiverse theory is a theory that's developed largely as the result of string theory and other physical theories that fit mathematically together. It's the idea that our own universe that has certain forces and physical constants that kind of govern the way physics works is not the only universe, that there may be other universes that are governed by perhaps different kinds of physics and have different physical constants that govern the way things work.
According to this theory, each universe starts with its own Big Bang, and as it cools, it develops its own distinctive characteristics.
So ours would be just a speck in this grander universe of universes.
That's right.
The idea that there's a multiverse is completely consistent with what we've seen, because after all, if there are other universes that are beyond anything we can ever observe, they're perfectly consistent with everything we've seen.
There isn't a multiverse theory. There is a struggle for justification of such a concept.
Yeah, a concept of a multiverse does sound really interesting to me. I mean, the first thing that comes to mind is like the parallel universes from like superheroes when you're a kid.
The multiverse theory is a very bold speculative theory. And in my view, it's not a scientific theory, it's a metaphysical theory.
It's impossible observationally to confirm a multiverse because we can't see outside of our own universe. At one level, the implications of a multiverse are similar to implications we've already faced when we realized that our Earth was not in the center of our solar system and that our solar system was not the only star system in the galaxy, and in fact that there were countless, not countless, but billions of other galaxies in our universe. To think that there might be also many other universes is just one step beyond that.
Physics, of course, tries to be quantitative. We try to make as many predictions as we can. And of course, it is a question people want to know, will this approach fail? And the answer is the only way we'll know if it fails is by using it as much as we can, trying as hard as we can, and seeing whether there just reaches a point.
Some people have been upset at the threat of theism. And so they say, well, maybe there are just trillions and trillions and trillions of universes, all different laws of nature, and ours is just by chance the one where carbon-based life is possible, a sort of winning ticket in what you might call a multiverse lottery.
They haven't been able to come up with one thing in nature that actually makes any sense. I mean, it's like you have a theory. I have a wonderful theory about why elephants are found in zoos. Because there are ice cream stands in zoos, and elephants like ice cream. And so you test this theory for the guy, and they say, well, wait a minute. I put ice cream next to an elephant, and he didn't eat it. Oh, forgot to tell you, it doesn't work on Thursday afternoons. And keep making it more and more complicated. And ultimately, this guy can say, with all honesty, my theory has never been disproven.
If we look at the history of science, at every epoch, there was a set of ideas, of hypotheses, which did not belong to the science of that time, but they belonged to some belt surrounding science of those times. But science is expanding, and what does not belong to science today could belong tomorrow.
Even if there are many, many universes, and ours is just kind of unusual in this large statistical sample, why is there even one universe where conditions would be such that life could develop, and develop in such a way to become self-recognizing, to become conscious, to be able to ask of itself, why am I here? Why do I exist? Is there a purpose?
This latest theory, the multiverse theory, is highly speculative. Modern physicists are steadily uncovering more evidence supporting the conclusion there was indeed a Big Bang of some kind. One reason some scientists are rationalizing these new theories is to exhaust all possibilities and trying to say, perhaps, that there is no God, no higher being with the power to say, let there be light, and create something as complex and magnificent as our universe. These theories are logical attempts by smart people to explain a question that has puzzled mankind since the beginning. So let's examine one final possibility. What's the likelihood that everything that happened was by accident? How likely is it that the creation of the universe was simply a random event?
Contemporary science, cosmology, physics, and other mathematical sciences show that the universe is mathematical. He is made out of mathematics from the very beginning to its top. Mathematics is a peak of rationality.
Consider this. If one of the gravitational constants of this universe were off by just 1 part in 10 to the 120th power, which is a fantastically small number. If the gravitational constants were off by that much, as the Big Bang progressed and gravity came into play, matter as we know it would either be constantly blowing apart or collapsing in on itself.
Random means there's just kind of no meaning and it just happens, something just happens kind of by accident, or just there's no pattern to it.
Random means that there's no way to know what's coming up.
And then there's something called Penrose's number. It expresses how finely tuned the Big Bang had to be for life to be possible.
For the universe to be able to develop complicated things like life, it had to start with extremely low entropy. Roger Penrose, a famous English mathematical physicist and a close friend of Stephen Hawking, calculated how low the entropy was at the time of the Big Bang. He found that the likelihood of the entropy being so low by pure chance was 1 in 10 to the 10 to the 123rd power. That number contains more zeros than would fit in our solar system if they were printed in 10-point type.
Very often, mathematics is very demanding. I must know something which I do not know at that moment. And when I hit into such a difficult problem, then I feel that I am not prepared to deal with it.
While numbers may not lie, it is hard to comprehend such large astronomical odds against random occurrence. Let's bring this conversation of random existence not just closer to home, but under your skin.
So there's no carbon in the early universe, and there's only one place in the whole universe where carbon is made. It is made in the interior nuclear furnaces of the stars. Every atom of carbon in our bodies was once inside a star. We're people of stardust made of the ashes of dead stars. And it's a very beautiful and very delicate process and very finely balanced. You've got helium, and if you could make 3 helium nuclei stick together, that would give you carbon. Now, it's impossible with things like nuclei to stick 3 together at one time. So, okay, you say, we'll do it bit by bit. Stick 2 together, that will make beryllium. Hope it stays around for a bit. Another helium comes along, attaches itself, bingo, we've got carbon. But the trouble is, beryllium doesn't stay around very long. It just disappears like that. Therefore, you have to be very, very quick indeed, in catching that extra helium nucleus.
If that energy level had been only a few percent different, it simply wouldn't have worked. The beryllium would have fallen apart too quickly. If it had been set the other direction, a little bit higher, then all of the carbon would have been able to receive easily another of these helium nuclei and become oxygen. Either way, we simply wouldn't have enough carbon to have the carbon chemistry for our bodies.
Carbon forms the building blocks of our existence. Could it have been a random event that carbon is an essential element of the universe? And then there's another foundation to life: water.
There are only 2 substances known to chemistry at all. There are only 2 substances which get bigger when they freeze. Everything else shrinks. One of them is type metal. And there's only one other substance in the entire world. And guess what it is? Water. And if water didn't expand when it froze, the oceans would be frozen on the bottom. And there'd be no possibility of anything happen, even if you had all these wonderful chemicals of space, which were created in stardust, dark parts of the galaxy. And those things, those which presumably these complicated molecules which rained onto Earth, fell into the ocean, started this thing which we ultimately call living beings. Would never have happened because you wouldn't have had any place for it to go. The oceans would be frozen, except for a little bit on the top.
So even if there is an argument to be made that this is all random, do either the math or any other theories support that conclusion?
What seems like a very fortuitous coincidence, these fundamental forces and constants that govern our universe seem to be just right for what we need to have life to develop and to be sustained stably. Either our universe is very unusual to have these particular fundamental forces and constants, or else we're just a random accident in a large number of universes. A lot of times the multiverse theory is brought up to kind of explain away the sense that we have that the universe seems just very comfortable for us to exist.
The numbers for this to be a random chance, and one can look at how many things have to stand, it's like saying you got a hurricane. And at the end of a hurricane, somewhere, you find a needle or a pin standing straight up on a pebble or something, standing straight up as a result of a hurricane. I mean, the odds of that happening, would anybody believe that after a hurricane you come back and you find a needle there?
We've seen evidence of the Big Bang Theory. We've looked at the major variations of the Big Bang Theory, and we've looked at the likelihood that this is all just a coincidence.
Can we explore, scientifically and mathematically, whether or not everything that happened to form our current universe was deliberate?
Mathematics is a very, very powerful instrument revealing us the mysteries of the universe, which are completely inaccessible to our eyes and our ears.
For some of us, at least, we say that science has found order in the world, an extraordinary amount of order.
If things are too rigid, too regular, then they are too rigid for anything new to emerge. Of course, if they're too chancy, too haphazard, anything that might emerge will not be able to persist. You need this very subtle balance between the two. For example, think about biological evolution. If there were no genetic mutations, there would be no new forms of life on which natural selection would act. If there were genetic mutations all the time, no species could establish on which natural selection could act. So you need a bit of genetic mutation, but not too much.
One can say that those constants are tuned to allow life, but one might also think that life has developed consistent with those constants.
You know, doing science is, to a large extent, looking for beauty in the universe, for the coherence of the way things hang together, the elegance of the simple equations, the mathematics that works.
I think life is too beautiful and complex and amazing, and nature is too amazing for there not to be some sort of intelligence behind it.
It's certainly the case that the world has to have the kind of physical laws that enable you to have a balance between chance and necessity, between openness and regularity. That sort of balance between chance and necessity, built into the very physical fabric of the world, is probably a necessary part of the universe having such a fruitful consequence.
If we didn't have that very, very close balance, we would probably not be here. I shouldn't say just probably. We wouldn't be here.
This universe is so perfectly tuned for life, that's unbelievable. The laws of physics came out of that instant. And a lot of things could be slightly different. But the laws of physics, which is what we scientists call the way nature works, could all be slightly different in a zillion different ways. And every one of them is perfectly tuned for life.
I think that almost all our concepts are inadequate when we compare them with the reality of the universe. And it is highly possible that also our concept of the beginning is not quite adequate. There could be a beginning, there may be no beginning, perhaps there is some other option.
we usually associate some kinds of order with purpose. When something isn't random anymore, we associate it with purpose.
We examined the beginning of the universe through the most logical and trusted theory, the Big Bang. We examined some interesting ideas of what might have happened before the Big Bang. We even explored the question of whether everything in nature might have been created randomly, which leads to the elephant in the room question for scientists. When does it make sense to put science aside and look at this from a perspective that reaches beyond science or physics?
It looks as if the universe has, in some extraordinary way, been put together so that intelligent life could emerge. If you look at Genesis, there is the statement, "in the beginning." But you can't be sure exactly what that means. But it didn't necessarily mean that, wham, the universe suddenly came out of nothing.
So science cannot prove or disprove the existence of God?
Even scientists of faith agree about that. But what we do have are two open doors, one marked physics and one marked metaphysics.
Since we've already examined these issues through the doors of physics, it only makes sense that we also look through the doors of metaphysics to see what we can discover. Metaphysics is the study of universal realities that cannot easily be explained or discovered by science. It is the most logical door to look through next.
Well, as you know, if physics can provide evidence for a beginning, that is a point at which the universe actually came into existence. And prior to that point, the universe would have been nothing. Not a vacuum, not a void, not empty space, but literally nothing. And if that were the case, we're no longer talking about physics. We're talking about absolute nothing. And now we're in the realm of metaphysics. If from nothing only nothing comes, and the universe came into existence, the universe, when it was nothing, could not have created itself because it was nothing. Something else, not the universe, something else would have had to have done that. And that something else would have to transcend the universe.
Before the Big Bang, that almost goes into, I guess, negative forever. It's like, it's just infinity, and it's sort of like a timeline you can't really get your head around. So, I mean, before the Big Bang, I guess you'd have to understand the concept of nothing.
So such thing as more nothing, less nothing, there's just nothing. The point is, if you have absolute nothing, then, and the universe was that absolute nothing prior to its beginning, what metaphysicians say, well, the universe can't create itself. These are the questions that we have to ask ourselves. Do I really believe that the universe can explain itself? Do I really believe that the universe can create itself out of nothing? Do I really believe that the anthropic coincidences can be answered by the universe itself? And if not, do I believe then that there is something required outside of the universe to explain how something like the universe came out of nothing?
That space was created at that time. Time was created. Matter, they were all created out of nothing. But there wasn't, nothing isn't, you can't even conceive of nothing. There was no space. So there wasn't like this empty space, because empty space is something. So if there is a creative entity, if this thing coming out of nothing, the creative entity has to exist outside of time and outside of space. And that's very hard for anybody to grasp.
The universe as seen through the scientific method is valueless. And this is why our existence, the existence of human beings, seems pointless in the universe. But in fact, we are not pointless. The method we have created just does not see values through which we are all impregnated, so to speak. And this is why we should be more open-minded. We should be aware of the fact there are limits of scientific method, and the limits of this method do not coincide with the limits of the universe.
If I could know for sure that there was an intelligent mind behind everything, how would that change my life? I think it would just make my life even more full of meaning.
The fact that the universe is understandable in a rational way, which is part of the whole imagery, both of the atheists and the theists, I think is because there is a rational creator behind it. That you have a very difficult problem explaining the fact that the universe is intelligible. It's one of the most interesting pieces of evidence for planning and design in the universe.
Perhaps cosmologists look out in the stars or the heavens, not solely in a quest for material knowledge or for science. Perhaps there is something even greater to discover.
When I contemplate the vastness of the universe, in particular when I look at these deep fields we observe in astronomy that show countless thousands of galaxies, and I think about how many stars are in each galaxy, and the fact that we're sitting in some little galaxy just like all these others called the Milky Way, and we're just one star, I do have this most amazing sense of humility.
Always wanted to try and hold things together. I believe in the unity of knowledge, to see how my religious beliefs and my scientific beliefs somehow fit together in a way that's consonant, makes sense of each other. And of course there are puzzles along the way, and I don't say that I have the answer to all the questions, but I've never faced a sort of crisis situation. I've never felt that I had to choose between my religious beliefs and my scientific beliefs.
I don't think science should be the foundation of anybody's faith. I mean, there's plenty of reasons to believe in God besides physics. There's all kinds of proofs for the existence of God from philosophy, proofs that come from what we call an unconditioned being, proofs from the complete intelligibility of being, even proofs from the nature of consciousness.
What we call the laws of science are our best description of what we see in the workings of the world around us. But that's not the same as understanding meaning. We're scientists, and I'm a scientist. I'm also a human being. And that's a different thing.
Understanding the universe in a moral and ethical way, which seems to be lacking if you're just trying to look at it totally materialistically. I cannot prove that there is more to the universe, but I would have to say that I'm psychologically incapable of believing in a universe that has no purpose or intention. So I'm going to look at the universe as God's universe, that somehow there is a creativity about it that brings life out, and life not just in reproduction over and over again, but building up to something that can think creatively and can make critical judgments.
I'd like to thank Dr. Stephen Barr for joining us, and I'd like to thank you for coming along on this journey through space and time. Clearly, this is evidence that needs some serious consideration. What do you think?
If there is indeed a grand design to this universe, how does that shape your life? Does it give your life more meaning? Does it lift your purpose to a higher level?
And so I think that science, because it's found order in the world, at least for me, strengthens my hope that there is a purpose to the world. And that it's taken time, and it's still something I think about. It's it would be much. We have to, I think all of us, whether we are religious or not, it's hard to believe in a meaningless world.
So when I think about being a part of the universe, I am so grateful that I am part of this universe, even for the small amount of time that I get to be here. And I think sort of outside of science, and I think sort of philosophically and theologically, I do feel a great sense of gratefulness for being part of this marvelous, marvelous creation, if you will.
Something larger out there than myself. I mean, when I reach out for something, I feel like I can get a hold of it.